6.7, as we continue to learn about different types of logarithms, we're going to talk about common logarithms. Now, common logarithms are handy. Well, back up a second. I'll tell you why they're handy in a second. But common logarithms are logarithms with a base 10. Okay, so any base 10 logarithm is called a common logarithm. And the reason for that is that they show up so frequently because we have a base 10 number system, and because when we talk about orders of magnitude, we're typically talking about powers of 10, 10 to the second, 10 to the third, 10 to the fourth, 10 to the fifth, and so on. These types of logarithms show up very frequently. So anytime we have a log base 10 logarithm, we are going to typically not write the 10. And so if you see a logarithm without a base, that means that it is a base 10 logarithm. It is assumed that there is a 10 there. Again, these show up so frequently that we don't write the 10. Okay, and the other nice thing about base 10 logarithms is that every calculator that has the capability to compute a logarithm will have a log button, a log base 10 button on it. So for instance, if you want to compute the log of 0.5, you can just type functions, and you can see, I should put that on the screen, I guess. You can see that there is just a log button right there, log 0.5. And then in the graphing calculator, there is a log button as well. You can see it's right here by the 7, just log, that's log base 10. Okay, and so from there then, you've got, sorry, my microphone is messed up there. So that's it. So we just write down the answer. We usually go to 3 decimal places, so that is negative 0.301 for the answer there. All right, so let's learn a new formula as well. So we're going to learn the change of base formula. The change of base formula is really handy for evaluating logarithms that are not base 10. Okay, so if you, here's the way that it goes. If you have log base b of x, you can break that into log of x over log of b, log of the base. And again, those are common logarithms. So zoom in a little bit here. Okay. Those are common logarithms. So again, you can just put those into your calculator. So if I have log base 3 of 16, I can use the change of base to approximate that. I don't need to do anything fancy mathematically. I just take log of 16 divided by the log of 3 and compute it. So I'll show you that in the calculator. You just take log of 16 divided by the log of 3, and there's your answer, 2.5237. Now, in Desmos, you can actually do just the log with the base command, and you can go at it that way. You'll see that, like in the next one, we can't do fractional bases in Desmos, so it's still actually easier to use the change of base formula. But like your TI-83, 84, those I don't think most of them have a log with a different base button. So the change of base formula is helpful. It's also helpful for solving equations, so it's really a useful formula. Let's do this one real quick. You might try this one first, see how you do, but this is just going to end up being log of 2 divided by log of 1/2. And when you compute that, so we'll just do the same thing here, log of 2, whoops, divided by log of 1/2, 1 divided by 2, whoops, 1 divided by 2, we get negative 1, okay? I wrote down the answer for the other one, and I forgot what it was, but you guys all saw it on the screen. Sorry about that. That's the change of base formula. Now, let's apply this formula, and let's see how we would solve equations like this, where we have 4 to the x equals 19. The question is like, well, what am I going to do with that, right? I can't write 19 as 4 to some power. That's been the technique that we've used for a lot of these problems. I can't do that. I can't write it as 2 to some power either. Like I could write 4 as 2 to the second power. Not an option for 19. So here's how we're going to do this. We are going to take the log of both sides, log of the left, log of the right. So we get this, log of 4 to the x equals log of 19. All right, so with that, sorry, I didn't write that very neatly, but with that, I still have a problem because the x is up here in the exponent, but I have a property of logarithm that says I can take this log and throw it out in front, or sorry, take that x and throw it out in front. So I'll do that. So I have x times log of 4 equals log of 19. Then I can solve this because remember, log of 4 is just a number, right? So I can take and divide by the number. It's like if I had x times 12, right? I could just divide by 12. So I'll just divide both sides by log of 4, and I'll get my answer. So x equals log 19 divided by log 4. And I'm going to get 2.124. All right. Do the same thing over here. I'm actually we'll just, I'll do that real quick here. So you might want to pause the video and give it a try. I'm just going to run through it real quick so you get the answer. So it'll be log of 6, the x, or the x out in front. So I get x times log 6. That equals log of 42. Divide both sides by log 6, and you should get log of 42 divided by log of 6, and you get 2.086. All right. Let's do a problem that is slightly more complicated here. So we are going to do solve 3 to the x minus 1 equals 4. I'm going to approach this in the same way. So I'm going to take log of both sides, log of the left and the right, and then when I move this out in front, I'm going to have x minus 1 times the log of 3. This is going to be equal to the log of 4. Now again, try not to get confused by this, right? Because log of 3 is just a number. It's like, you know, x minus 1 times 15 or something. Like, we just need to divide by it and then finish out the math. So I'll divide both sides by log of 3. Those cancel out. And then I'll get x minus 1 equals log 4 divided by log 3. That's just a number that I can figure out in the calculator, and then I'll add 1 to both sides. So I'll end up adding 1 over here and adding 1 here. And so here's what I get for x. Log 4 divided by log 3. And then I can actually just put the entire expression in Desmos. I'll show you here. So then we can just put plus 1, and we get 2.262. All right. And then the last problem here is an inequality. An inequality, the same properties are all going to apply. So an inequality like this, we can apply the same method. So we can take the log of both sides. I'm going to kick the 2x out in front, so I'll end up with 2x times log of 5 is greater than or equal to log of 42. Again, log 5 is just a number, so I'll divide both sides by log 5. I get 2x is greater than or equal to log of 42 divided by log 5. So I'm going to actually compute that real quick. So let's go over here, I guess. So log of, what did we say here? 42 divided by log of 5. And so we'll get that answer is 2.322. And then I'll divide both sides by 2. So my final answer is x greater than or equal to 2.322. Whoops. Actually, we just want this whole thing divided by 2. So 1.161 is your final answer there. And so that's really all there is to it. Common logs are very, very helpful for solving way more logarithmic or exponential equations, way more exponential equations than what we were able to solve before because of that property where you can kick the exponent out in front. And then because logs have, again, they have a button on a calculator, so it makes the computations much quicker. And that's really all there is to section 6.7.